Moving on, this is part 3 of the assignment. So now we have this full circuit and we need to break down and figure out all the things going on, all the pieces, the voltages, what's the current going through the whole circuit, all that good stuff. So the best thing to do, and it asks for it in the right order, so it makes it a little bit easier, but it says first, what's the R total? Okay, and my R total, it's in series, means I'm just going to add these 3 resistors because they're in parallel. I'm series. Because they're in series, you just add them all up. So R total is nice and easy. It's just going to be 470 plus 1,200, the 1.2 kilo, right? Just as 1,200, and 270. So I add those two together, 470 plus 1,200 plus 270, and I get 1940. Oh, which was not the year I was born. Okay, so our total is 1940. Nice and easy. So there's my first answer, but it's also more important to know that that's what we'll use to figure out everything else. So next thing we know is we have our Ohm's law, right? That Ohm's law is very, very important. V equals IR. And Ohm's law can be used for the entire circuit when talking about total resistance and total current and total voltage, or it can be used for just one resistor. What's the voltage across this resistor? Use Ohm's law, and so on and so forth. Okay, so we need to get the I total here next. So my I total, we're going to use Ohm's law, V equals IR in terms of totals. So my total voltage is 9 volts. My total resistance we just figured out, we just need the total current. So V divided by R will be my I. And I have 9 volts divided by my resistance, which was just figured out, 1940. So I have 9 divided by 1940, and I get 0.00464, basically 464 amps as a current. Okay, so think about what's going on. So now I have this current. We just figured out the current leaving the battery is going to be 0.00464. All right. Now, this series circuit, in series, currents don't get split up. Okay. Picture a river. When I follow this along, the current is not split up like parallel. So 0.00464 is going to go through here. Okay. It's going to be the same current. 0.00464 is going to go through there. 0.00464 is going to go through all of these with the same amount of current. There's no splitting up. All right, so then we go to R1 and we want to know what V1 is going to be. Well, V1 is just going to be V equals IR. Our I will be the same value. It doesn't get split like I just said. So I have 0.0 and then I'll put a 1 there. 0.00464 times my resistance of 470. And I get an answer of 2.18. So this is going to be 2.18 volts. Okay, I do the next one, and that's going to be my 0.00464 times my 1.2 or 1200 ohms. All right, multiply that out, and I get 5.568. Okay, which you could round up to 5.57. All right, finally, I have 0.00464 times 270, 0.00464 times 270, and I get 1.253 volts. Okay, now there might be a little bit of rounding, but I want you to notice the last thing again for series circuits. In series circuits, all 3 voltages here have to add up to the total. So in a series circuit, the current stays the same throughout, and the voltages add up to a total. So if I go down here and I say 2.18 plus 5.568 plus 1.253. Okay, and I add those up, and let me do that. 1.253 plus 5.568 plus 2.18. I get, oh, look at that, 9 volts, because it has to add up to the total.